Okay. So I guess I started recording the lecture, and I guess we can start our lecture. Good. We are on time. So welcome everyone. Today the lecture is basically about the microelectronics design EE341. So the lecture what we are going to do is today it's just about the course overview, introduction to microelectronics, why and what of this course, why you are taking this course. Since it's a core course, that's one thing, but why this course is of much value. I'm going to talk about these things and also what is like demanding from this course and what this course asks. Okay, and before proceeding, I will briefly introduce the instructor. So I am Avasmin Altaf. I'm going to teach along with Dr. Wala Saade. So we both are co-instructors. I will describe the content, that how we are going to manage the course, but like uh, initially, like Dr. Wala will take lead. Before the mid, pre-mid, she will mainly focus, and post-mid, I will mainly take the lead. But today's first lecture, I am starting the first lecture. And during the lecture, if you have any concern, questions, please make sure to raise hand, or even in the first lecture, at least you can directly uh, ask the query if multiple people are not asking. But during the lecture in future, I guess it would be better if you just raise your hand and we can have someone uh, answer your query. Okay. So let's start the lecture. So the overall info about the course, as I just mentioned, the course is going to be taught by two instructors, Dr. Wala and me. So room, we are not going to meet in class. The mode is basically through Zoom. So we are going to continue meeting Zoom even after 1st of Feb as previously scheduled. Office hours, currently we are putting two slots, Monday 11 to 12 and Thursday 10 to 11. We try to find 10 to both are AM and the 12 till noon PM. So we try to find the slots which are basically, let's say, not if somebody has a class on Monday, then this means we try to avoid the Wednesday slot. But still, if you feel these slots are not suiting majority of you, please make sure to send an email to us. We will find another slot for you. If you have any query, you can send through LMS an email, or you can also just directly contact us over our emails. The emails are provided here, and also you can just search on your email link. So the teaching assistant for this course are Ishatif and Ali Samek. They are your seniors, and they're in the final year now, and they took the course and last year, and they are pretty much accomplished to answer your queries. Their office hours are going to be detailed in the due course, most likely within this week. We'll tell them to share their office hours, and we can just see how we proceed further. Moving forward, the course basic, yes, is a 3 credit hour course. Mainly it's a lecture-based course, so we are going to meet 2 times per week, and each lecture duration is going to be 75 minutes. There will be some tutorial and recitation sessions which we are going to decide. They will not be per week, but as whenever you have some, like we cover some content, and when there are a lot of problems, either one of the instructor or the TAs will hold these sessions. They will be it's not again mandatory, but definitely they will be recommended and they will be helpful for you. Regarding the course modalities, we are going to do the synchronous Zoom sessions. Recording will be made available after the class, but the synchronous session is going to be today. We are going to, like I am talking at this moment live, but next time what we are going to do, we will record the lecture, but we will play at the class time. But the instructor is going to be available for the Q&A at that slot. So it will be synchronous. Since any query, we will just pause the lecture and we will respond, so that we make sure both the sections are going with the same pace and we avoid any material which is left for the other section. So it will be synchronous, but the synchronous with the lecture recorded a little bit pre-ahead, but it will be available after the lecture slot. And you will need definitely a laptop, a PC. We like not recommend you use mobile, but then because then you lose basically the overall tempo. So internet connection, speakers, and microphone are recommended, like so that you can also talk. So microphone is important. Seeking help, Zoom office hours, TA office hours, when they are going to be announced, please make sure to come in the Zoom in the TA office hours and also the instructor office hours. You can use the LMS discussion boards, and the course website will be definitely on the LMS. Nitty-gritties for the course, like better way, as most of you are already doing, display name, your first name, your campus ID plus your first name and last name. Microphone should be muted by default all the times, as all of you are again doing. It's great. Only unmute if you wish to speak, or you can also raise your hand. But again, it depends upon how the things are going. If, for example, in today's environment, it's more like an introduction, I would like no need to raise hand. You can ask, but if you feel that it's becoming crowded, or I can myself interfere and I can tell, please raise hand. So there is no fixed or hard rule. We just don't want it to become a machli bazar. We just want we all learn and we all listen, because it's not going to be only you are learning from me. I am also going to learn a lot from all of you. Video recording, as I mentioned, the recordings will be available after the lecture, but I highly recommend, don't rely just, okay, you will watch the videos later. This course is a design course, and design course come by learning, by recursion, by repeating the things and getting the concepts. So it's a different from math, and a different, that math you need to do recursion, you need to revise the thing. But the important thing is that there are concepts, the fundamental concepts, which are going to be built on top of each other. So if you miss something, make sure to cover that up early. Don't take, okay, you before the made up, before the quiz, you will see the things. No, it's not going to help you, as this course is a design course and a fundamental course, but still you have to make sure you cover up all the aspects. Course description, it's a core for electrical engineering BS, electric for MS, BS, CS, and physics students. It's open for student category junior, senior, and MS, but closed for the freshmen and so for more. The course description, this is a core course in the area of microelectronic circuits. It teaches essential techniques required to design, analyze, and simulate modern analog circuits for a wide variety of applications. I'm going to come to this modern analog circuits, or rather, let's ask now, what are analog circuits? Have you seen any analog circuits till now in your courses, in your EE content, or in journal in your life? What type of analog circuits you have seen? Anyone want to just jump in and describe to us what analog circuits they have seen? So I can pick myself if nobody is going to tell, like Hamza. You want to tap in? You can unmute yourself and just tell what type of analog circuits you have seen, or anyone else. It's not only Hamza, but just I want, like, if we have a two-way traffic, it's going to helpful at least for the first lecture. Anyone else want to tap in? Ji Hamza.
Sir, I don't know. These electronic clocks.
Electronic clocks are both analog and digital, but we mainly have nowadays digital clocks. Or any other analog circuit you use anytime, microphones, speakers. Whenever you are going to interact with the real world, means, for example, any real phenomena, when you are talking, you want to process that signal, you need an analog circuit. Why? Because anything in the environment is analog. Okay? So whenever you want to process that signal, you want to take that signal, you need an analog circuit. आप बात कर रहे हैं, your speech is analog signal, it's not digital. आप बात कर रहे हैं, it's an analog signal. तो सिग्नल को प्रोसेस करने के लिए, मोबाइल में माइक्रोफोन में डालने के लिए, स्पीकर से बाहर निकालने के लिए, यू नीड सम एनालॉग सर्किटरी. ठीक है, जो आपका मोबाइल फोन होता है, इसमें जो टच स्क्रीन होती है, इट्स अगेन you have a real hands, you won't touch this thing. What it is going to be a analog circuit. So ये जो टच स्क्रीन होगी, it's going to be an analog. जो आपका मोबाइल फोन में सिग्नल कम्युनिकेट करता है, how the signal is communicating, the signal is also an analog signal. तो उस एनालॉग सिग्नल को डील करने के लिए यू नीड एन एनालॉग सर्किट. ठीक है, जो आप हॉस्पिटल में जाते हैं, whenever they put some devices on you, for example, they want to measure your PPG signal, ताकि आपके SpO2 कंसंट्रेशन मेजर कर सकें, जो आजकल कॉमन है बिकॉज ऑफ द कोविड-19. So they measure your SpO2 concentration. What is that signal which is coming from your body? Analog signal. ठीक है, processing हो रही है, but to process that analog signal you need analog circuit. Same thing जो आपके पास ECG, अगर आप hospital में जाएं, God forbid you have to record your ECG patterns, that's also an analog circuit. EEG जब आपका लिया जाता है in again hospital or in a home environment, that is again an analog signal. तो जो भी real world का आपके पास signal होता है, that is going to be an analog signal, and you need to have analog circuit to deal that thing. So all your applications, automotive, your cars, your planes, anything you name it, they are basically analog signals. And then you take that analog signal, you process, and then you digitize it and do the remaining in the digital domain. So like things start with an analog circuit. So that's why they are there from ages, and they are going to remain there, because हम लोग अपने आप को या वर्ल्ड को खत्म नहीं कर सकते. So that's why it's very much important to understand, to analyze what are the techniques to deal those analog circuits which are in wide variety of applications. Okay. So the topic which we are going to cover, they will be definitely of fundamental nature. It's not an advanced course, it's a fundamental course. So it's going to be built on top of it your devices course, where you have seen, I guess, the small signal analysis or large signal analysis. So here we are going to cover the amplifier, starting with an amplifier, the single stage amplifier, since whenever you have any signal analog you want, it's going to be very much small value. In the real world, it's going to be covered with noise. So you want basically to amplify that signal, the first and the most important thing. So you need amplifier. So we will study the single stage amplifiers. Then we have cascade, in which you have some like a parallel approach sort of stuff, or you increase the gain somehow. Then there is a current mirrors. We are going to talk in this course about current mirrors, how you mirror the current value into different domains so that you can have a power efficient and robust approach. And the differential amplifiers, what are the benefits? Again, we are going to talk about these things. And then the operational amplifiers. So we are going to cover all of these aspects in this course. The concept of frequency response, most likely you are going to take parallel in the control course to control and feedback. The frequency response, that why we need to see a signal in the frequency response. Since we are in analog domain, we need to see signal in both time domain and frequency domain. So we need to understand how we can analyze a signal in frequency domain. So it's a frequency response. Then we see the feedback and stability in circuits. Like in general, you will see the feedback concept in overall bigger systems, but here you are going to see the feedback concepts in the circuits. कि आप एक amplifier design करते हैं, एक signal आप लेते हैं, उस signal को आपने amplify करना है, then you want that system to be stable. Stable in a sense कि ऐसा ना हो कि वो voice shout करना start कर जाए. For example, जब भी आप microphone लगाते हैं, a lot of times what happens, scream starts. आप बोल रहे होते हैं, but it starts screaming. This means the system is not stable. It needs tuning to make the system stable. Okay, so that stability concept, the same thing. So you want the system to be stable. Oscillators and PLL, we will discuss them, but we are not going to go into the detail of these things because that's not the main thing. But we will just tell what are oscillators, what are PLLs, and then we are going to use some SPICE tools. It's not like a lab intensive course, but still we are going to use like an assistance where you can simulate your circuit. So we are going to use LT SPICE, and that is an open source simulation tool where you can simulate analog circuits. Also, I guess you can simulate the digital circuits, but we are going to use LT SPICE in this course. And also, if some students are interested, we have industry standard tool available with us. We are not going to use in a regular class, but if somebody want to excel and want to learn beyond the course, we have a cadence which is for the designing your real mobile phones, for example, how the things are designed. We have the access to that, and we use in the graduate courses, so you can also utilize that if you are interested in those aspects. So that's in general about the course description, and about the overall why we are doing this thing. As most of you are familiar, you have taken the devices course about the CMOS, means complementary metal oxide semiconductor technology is currently the industry mainstream for vast majority of applications, as compared to the bipolar junction transistors, which were there a couple of decades back, but now everything is CMOS and is common in analog integrated circuits. Your all mobile phone which you are using, your gadgets, your laptops, everything has CMOS basically. Majority of the things is CMOS. You see any electronics, at least the consumer electronics, most of it is MOS based, meaning where the bulk electronics is junk is MOS based. Why? We are going to talk a little bit about it in a while. So we use in the digital IC integrated circuits and mixed signal integrated circuits. Okay. So most modern day consumer electronics, including your microprocessors, the one where you are at this moment, you are laptop, mobile phone, everything has a microprocessor where the processing is happening. It's in the digital domain, but still CMOS is used. And why the analog is important? Because you need to give a signal to the processor before it can be processed. ठीक है, आपकी वीडियो जो है, वीडियो is an analog signal. Some camera is capturing that video, and then we are using some A to D converter, analog to digital converter, and then we are doing processing and featuring, and then you are able to see me. But the camera is a sensor. It has analog sensor, which is going to have some amplifiers, and it's going to take those pixels. So the same thing as an amplifier is there. And the digital cameras, which we use, also initially they take an analog capturing, and then they do the digital processing. So everything is implemented in CMOS. So CMOS is very much important. Though in the research we have more materials coming in, but currently what we are seeing is the CMOS. So this course aims to basically teach fundamental elements. Again, it's a fundamental course, and essential techniques to design and analyze microelectronic circuits for analog applications. So our focus is going to be on the analog side in this course. As I mentioned, the prereq for the course is your devices course, which all of you have taken, EE340 devices and electronic course. And I assume you have seen MOS there, you have seen the behavior, IV curves you have seen there, you have seen, okay, you can use it as an amplifier, or you have used some stuff in your lab, if I'm correct, if the lab was in on-site environment. But the devices and electronic course is a prereq for the course. So we'll start from the same point where you left in that course. So the learning outcomes, the course learning outcomes for this course, which are basically analyzing the building blocks of analog ICs, such as operational amplifier, cascade stages, current mirrors, differential amplifiers. You might not be much familiar with these terminologies, but within I guess 2 or 3 weeks, you will be familiar with all of these, because we are going to jump into these all very much soon. Then you want also analyze frequency response for various types of amplifiers and their building blocks. That's very much important also. Analyze feedback and stability in analog amplifier circuits. As I told you, that feedback is very much important. Why it's very much important? Because we want our system to work properly. I just gave a high-level example of a microphone where the noise or the backlash start coming, or the scream sound start coming, because the feedback circuit is not working properly. So we want the system to be stable, even in analog amplifiers. And then the design amplifier. So we want, like at the end, you should be able to design at least a basic 2-stage amplifier and building blocks for analog IC according to some constraints which are provided to you. Because in amplifier, what we have gained something that, okay, you need, your signal is of like a 1 millivolt signal, you want it to amplify 10 times. So that this means you have to have a gain of 10 times. Then you want some bandwidth, meaning frequency. एक सिग्नल है, वो कितनी frequency में लाई कर रहा है. For I can give you an example. जब हम बात कर रहे हैं, it's like from 220 hertz to 2k hertz, 20k hertz. So this means मैं उस band के 20k hertz तक के signal को amplify करना चाहूँगा. I don't want any other signal to be amplified. ठीक है? So I want only that signal to be amplified, so that that's in the audible range. So मेरा जो amplifier होगा, उसकी bandwidth should be from, at this moment, let's say from 20 hertz to 20k hertz. ऐसी होनी चाहिए. ठीक है? And then for which application I am using it. So very much important, power consumption. अगर आप किसी ऐसी application के लिए use कर रहे हैं, मोबाइल फोन है, you want to make it a power efficient system. आप ये नहीं कर सकते कि उसको हम क्या चाहते हैं, we want our system should operate for a longer duration. मैं 2 दिन बाद अपनी बैटरी चार्ज करूँ. I don't want it to charge my battery very much often, even if I use Zoom classes, even if I listen to videos, even I do whatever, but I want to charge my mobile after 2 days. So उसमें एक तो आपका बैटरी आ जाती है, battery should be of more capacity, but the other thing, your circuit should be power efficient. So power is a very much important constraint and depends upon application. अगर मैं बात करूँ desktop की, it's connected to power, it's good to be power efficient, but इतना ज़्यादा hard constraint नहीं है. Whereas gadgets, laptops, mobile phone, they have a hard constraint. Or if you talk about some equipment which अगर आप लोगों ने सुना हो regarding the जो आपके पास implantables करते हैं for stimulation of cardiac. So if you want some devices, those should work for a more month, because you are implanting them in your body. You don't want to charge it very much often. Okay, so it depends totally on the application. So analog circuits, the digital circuits, and general circuits with power efficiency and area efficiency, along with the gain, frequency response, and are very much important. Some other things like noise we are going to talk in this course also, so that's very much important. Noise कहाँ है? Any unwanted signal. मैं बात कर रहा हूँ, this is for example at this moment wanted signal. कोई और बंदा बाहर से आके बात करना start हो जाए, not relevant to this course, it's a noise for us. So that's why we need to also make sure this thing. So grading and breakup policy, one of the most important things, we are making assignments. We increase the weightage of assignments. So previously we used to have 15%, now we increased to 20%. So we are planning to have 6 assignments. So we will make sure to follow the pattern 6 assignments so that you can have maximum learning experience. We're going to have one complex engineering problem, that is a requirement of PEC, Pakistan Engineering Council, and also that's something when I was talking about the designing an amplifier based on the specifications. So here you are going to do that thing. So that will be in the last couple of weeks or 3 weeks. You are going to have a complex engineering problem where the specification will be provided to you, and you are going to do design first by hand calculation and then verify that on the LT Spice. So we put like a 15% weightage. Again, that's going to be a good amount of weightage, but that's something like जैसे आप कहते हैं ना निचोड़ के, that's something which we want you from the course कि आपने learn क्या किया है. Class quizzes, we are going to have 6 quizzes. In normal setting, we used to touch 8, but in the online setting, we just reduce the number of quizzes because it takes time. 15% weightage. We will describe whenever before the quiz they will be announced, so we will update you when we are going to have the quiz and what are the content being covered. So you can say 6 quizzes, meaning after 1.5 weeks there is going to be 1 quiz. Normal setting, as I mentioned, after every week we take a quiz. So in 2 weeks there was 1 quiz, but now like in 3 weeks there will be 1 quiz at least, so we can have overall 6 quiz. Midterm is going to be 25% of weightage, and the final is also going to be 25% of weightage. The things are again going to be linked. Any concern, any comment, you are free to update. Otherwise, I will just proceed. Examination detail. These are basically the main thing is that for the midterm and the final, both are going to be currently what we are seeing at this moment might be in home again, same environment which we have previously done. But if the on-campus opens, then I don't know how the things are going to be. But at this moment, we will have midterm exam and also you will have final exam. Duration will be definitely tweaked for the offline environment, but we are going to talk these things later. The textbook for the course is basically Behzad Rizavi, Fundamentals of Microelectronics. He's a famous professor in UCLA. He's like, you can say he's an analog guru, both analog and RF circuits. He has series of books in Fundamental of Microelectronics, then in Advanced Analog Circuit Design, then in RF, then in Devices Analog side. So he is basically the main person in this field. So the book also will upload, I guess, the soft form of the book. It's available. And as a reference book, we will also follow the CMOS Analog Circuit Design by Philip Allen. And any comment? All right. So, and we will also follow the reference book, Cedra Smith book. I guess might be for devices code. You're familiar with Cedra Smith. Again, Cedra Smith and Philip Allen are also the famous person in the electronics or in the microelectronics. You know, all of them are alive. All of them are professors in the university, and all of them are actively teaching. So Behzad Rizavi is also actively in research, but all of those, Philip Allen and Cedra Smith, are more now teaching professors. And for the course content, for the course lectures, most likely we will follow the Behzad Razavi slides also. So we will follow his slides even for the book. The slides are available, so we'll follow his slides also. The main and the important aspect, how to ace the course, I would say first thing, attend all the lectures with focus. Time slot is ideal. That's I would say. It's not early in the morning when you are sleepy, or when late in the night when you are like not again focused. So it's time slot is ideal. I hope at least it's ideal for me, and I hope ideal for all of you. So you can just uh, remain focused and you can learn the things. Ask questions, that's very much important. And every query is worth clarifying. Don't worry about anyone that, okay, why is asking this thing or why she's asking this thing. No, don't have to worry. You have to ask the question. Even if you don't ask now, you can come in the office or you can email me or email us, but make sure to ask questions. So whatever the query you have, answer, like let it not absorb it, make sure to clarify. That's very much important. Do assignments on your own to get the benefit, because you can just copy the things, you can get again A grade, but it's not going to help. That's why I'm writing the ace the course, not A taking the A or A plus. So that's not going to matter. What thing is going to matter, what you learn from the course. As a when you go like a 2 years from now, when you go into industry, when you go in for higher studies, what is the benefit from this course? Because then this is a fundamental course, you need these things, you need this skill set. So that's very much important. Discussions are definitely encouraged. Means we want you to discuss, we want you to share ideas, we want you to share the problems, we want you to share whatever the solutions you have, but in a discussion matter, not in a copying. So you copying will be definitely penalized. You learn from each other, that's the benefit of university. Right. I guess there was some small internet disconnect.
Assalamualaikum, sir. We cannot hear you.
Any you hear me now?
Yes, sir. You're audible.
Okay, that's good. So I'll just stop my video for a small time so that we can have the things. Right. So I just let me just check. So we can't just I just didn't see the chat, so let me just see this. Yeah. So there is a question that will we have sessions separately on how to use LT Spice? Yes, we can have a couple of, or based on that required TA sessions. For that, they will just describe how to use LT Spice. But normally LT Spice is straightforward, but definitely we are going to have some sessions, either one or two based on how much you need on the LT Spice. And the thing is the other is clear. Okay. So yeah, so where I was saying that we don't want to have a DC in the course. DC means disciplinary action. That's why please don't cheat. It's just a request, humble request. Let's learn the things, means not only the content but also some other aspects of the life. That okay, if the time is tough, there are difficult times. We don't want to have use unfair means. Okay, so don't worry on the grades. If you learn, if you do effort, you will get grades, but cheating is not going to help you at all. Might be you will get uh, I might not be able to capture you, that's fine, but it's not going to help you. But if you are captured, then unnecessary, we don't want an hustle. So the course is fundamental. That's I must say, but it's state of the art. Again, this is the same thing which are being used in your real life in the state of the art industry. As I mentioned, mobile phones Apple, they are looking for good analog designers. You go for TI, you go for Intel, all of them are looking for good analog designers. So it's state of the art, but yet it is fundamental. It's prereq for analog IC design course at LUMS or any university outside, top university. So again, if you ace the course, you are there. Ace the course meaning you just put an A plus and then you describe what you have done and you can answer the things at the interview stage. So that's all the things you need. And we have now international a little bit exposure about that. Okay, we are an analog or we are an integrated circuit university. We are doing the thing, so it will benefit you. And also, if you talk about Pakistan or industry in Pakistan or outside was all the time booming, IC design or electronics, core electronics. But in Pakistan also the things are moving fast nowadays. A lot defense sector, a lot private sectors are jumping into the things and they want basically something in the analog or in the digital IC design. So it's the very much good time to ace this subject and move forward. So I would highly recommend, even if you want to go outside for a job, stay here for a job or go for academic. Make sure to get maximum from this course because this is going to help you a lot. So that's the overall generic perspective of the course. Now what I'm going to do, I can just see if the video can be turned on. So if you have any concern, comment, you can just please update. Otherwise, I will just go a little bit generic introduction about the microelectronics and how the things move on. But if you have any concern, question regarding the course outline, regarding the things, you can please jump in. Course outline we will upload on the LMS today. And we'll mark which by the color coding, which content is going to be covered by me and which content is going to be covered by Dr. Wala. So as I mentioned, like most of the pre-mid material is going to be covered by Dr. Wala and most of the post-mid is going to be covered by me. But again, you are free to even send an email to any of us. That's totally fine. Right, if there is no concern, we can move forward towards an introduction. So in introduction, if we just see the main aspect is the Moore's law. So any one of you is familiar with Moore? Who was Gordon Moore? Anyone have an idea who was Moore? He's a person on his name, a law was established and named as Moore law. Just to update, he's basically the co-founder of Intel. He was a co-founder of Fairchild, one of the leading consumer electronics industry, and he was I guess co-founder of a couple of more companies. Okay, so he's the leading person in the analog IC design or digital IC design or even in generic integrated circuit or electronics, and he's still alive. That's important. He might be touching 90 or 100 years. He's like he gave this law way back in 1970s. So when there was no even bulk electronics, no your laptops are available, but he gave a law which says that the number of transistors, again quote unquote CMOS or BJT, he just used the word transistors per chip doubles every 24 months. What is this mean? Meaning he's saying if you have an area, let me just show. For example, if you can just see this thing, this is a chip, for example, a small chip. Okay, if this is, you can see my finger properly. If this is a small chip, ठीक है, ये जो आपके पास नजर आ रही है येलो या गोल्डन कलर में, yeah, all of you can hopefully see this thing. See this golden or yellow color, this is a small chip जिसको हम integrated circuit कहते हैं, जो आपके मोबाइल फोन के अंदर भी एक इतना सा सर्किट होता है which is doing everything. ठीक है, इसमें कोई एनालॉग सर्किटरी भी है, डिजिटल भी है, द रेस्ट थिंग्स आर पेरिफेरल. जिस तरह ये बोर्ड है ना ग्रीन, इसमें पेरिफेरल्स है. मोबाइल में बाकी चीजें पेरिफेरल्स होती हैं, मीनिंग वो कनेक्ट कर रही होती हैं, लेकिन जो मेन कोर एम्पलीफायर्स हैं, मेन जो प्रोसेसर है, दैट इज समहाउ दिस साइज. ठीक है, तो अगर आप उसको इस साइज को लें तो मोर्स ने कहा था कि इस साइज के अंदर अगर मेरे पास अभी जस्ट अगेन आई एम सेइंग सम नंबर्स 200K ट्रांजिस्टर्स हैं, तो 2 साल बाद या आफ्टर 18 मंथ्स इसके अंदर जो नंबर ऑफ ट्रांजिस्टर इसी साइज में वो 400K हो जाएंगे, डबल हो जाएंगे. ठीक है, दैट वाज द लॉ ही मेंशन्ड दैट इन सम साइज इफ यू हैव 200K ट्रांजिस्टर्स in 2 years in the same size you will have more or double of the transistors, meaning 400K, meaning आप ज्यादा लॉजिक इंसर्ट कर सकते हैं, ज्यादा काम ले सकते हैं उसी स्मॉल एरिया से. मीनिंग आपके पास जो ट्रांजिस्टर है, ये जो मॉस है, उसकी डायमेंशन छोटी होना स्टार्ट हो गई है, उसकी डायमेंशन छोटी हो गई है। पहले अगर वो 1 माइक्रोमीटर का था तो अब वो शायद 0.18 माइक्रोमीटर का हो गया। इस वजह से आप चीजें ज्यादा ऐड कर सकते हैं, ठीक है, श्रिंक हो गया है। अगर आपको याद हो, पहले आपके सिस्टम्स बड़े होते थे, अब वो सिस्टम छोटे हो गए हैं, श्रिंक हो गए हैं, बिकॉज ऑफ दिस channel length reduction, and that was predicted by Morse. He didn't do any calculation, he just have some insight because he was working and he gave this law in 1971. From 1971 until this time, somehow this law is being followed. अगर आप ये देख सकते हैं, this whole window here, यहाँ क्या है, all of those processors जो आपके आए हैं from 1970 to 2020. This also includes those microcontrollers जो आपने microcontroller interfacing की lab में भी use किए होंगे, जो 8086 हैं या आपके पास whatever the processors you have used, all of them are linked here, mentioned here. So these all are those things which are available and they are following the Moore's law. Definitely all the time we have this discussion, the Moore's law is not following anymore, but still the things are going. Now we are reaching this limit area, but till now the Moore's law is falling, and that's somehow one of the pushing force that we have to find more and more circuits, more and more techniques to move forward. के इसका फायदा क्या होता है, मैं चीजें ज्यादा ऐड कर सकता हूँ, I get cost benefit. चीजें ज्यादा एक स्मॉल एरिया में ऐड कर सकता हूँ, आई गेट पावर बेनिफिट। इसीलिए जब आप एक चीज नई हर 2 साल बाद एक नया प्रोडक्ट आता है या 6 महीने बाद एक नया मोबाइल लॉन्च होता है, पुराने मोबाइल की वैल्यू खत्म हो जाती है, इट डजंट हैव एनी वैल्यू। दैट्स व्हाई पीपल आर गोइंग मोर एंड मोर एंड देयर इज अ कंपटीशन इन ऑल दीज main brands just because of this Moore's law currently at this moment. But again, I mean, some people can argue that okay, after a couple of years, might be Moore's law is not going to be there. But these discussions are there for a couple of decades. For last almost 50 years, the Moore's law is being satisfied. So that's one of the main important things. And apart from this number of chips, जो मैंने कहा था number of transistor double होते हैं, how these things are linked. Yes, right. How these things are linked basically, if you just see this thing here. Right, let me just mark it. For example, आपके पास जो currently mobile phones हैं, आपको पता है कि what is the minimal channel length? Channel length का idea है आप लोगों को? What is the channel length? MOS में कितनी है, या जो आपके पास, जी बताएं इब्राहिम।
5 nanometers.
5 nanometer. What is meant by this channel length कि 5 nanometer है, इसका मतलब क्या हुआ?
सर जो इसका लाइक जो एन चैनल या जो पी चैनल बनता है, उसकी जो टोटल विड्थ है, सो इट्स बेसिकली दी जो मेजॉरिटी ट्रांजिस्टर का साइज होता है उसका चैनल लेंथ ही होता है।
ठीक है, so you are basically saying something correct, but let me just clarify. So होता क्या है, जो आपके पास एक MOS ट्रांजिस्टर होता है, if you recall your devices course, उसमें क्या चीज होती है? I am drawing, let me change a different color now. मैं ब्लू से ड्रॉ कर रहा हूँ, so you can most likely you can see. So जो MOS एक होता है, for example, इसमें क्या चीज होती है? यहाँ आपके पास सोर्स होता है, यहाँ आपके पास ड्रेन होता है, and then you have a gate here. ठीक है, MOS में you have a source, you have a drain and you have a gate. Source और drain form the channel, जो N type या P type जिसका इब्राहिम कह रहे थे, सोर्स और ड्रेन के दरमियान चैनल फॉर्म होता है। उस चैनल की जो डायमेंशन होती है, लेंथ, बेसिकली बिटवीन द सोर्स एंड ड्रेन द चैनल इज बीइंग फॉर्म। ठीक है, ये विड्थ होगी एंड ये लेंथ होगी। ठीक है, तो सोर्स एंड ड्रेन के दरमियान डिस्टेंस होगा, दैट इज बेसिकली नोन एज चैनल लेंथ। तो ये जो चैनल लेंथ है, जिस तरह इब्राहिम कह रहे थे, नए might be the TSMC or the Intel, the new one is coming at 5 nanometer. ठीक है, so what the technology you are seeing, processors are coming at this much node, 5 nanometer. You can see how much is the 5 nanometer. So transistor minimum size है वो इतना है, which is basically currently there. जो भी आ रहा है, जो आपके पास करंटली शायद आप लोग यूज कर रहे होंगे, माइट बी ऑन 10 नैनोमीटर और 14 नैनोमीटर दे विल बी, बट दिस सर्किटरी इज मेनली फॉर द डिजिटल। जब इतने स्मॉल स्केल पे आ जाते हैं, डिजिटल में तो सूट करता है, एनालॉग में डजंट सूट दैट मच। सो एनालॉग में वी वांट, still now we are having 45 65 nanometer 180 nanometer. It's not like we cannot create circuits at a smaller level, but there is no benefit of going for a 5 nanometer for analog circuits. हम कोर्स के कॉन्टेक्ट में थोड़ा सा डिस्क्राइब करेंगे, but that comes under the advanced category. लेकिन नॉर्मली ये होता है कि in analog, since we use resistors, we use capacitors, we use inductors, that's why those things doesn't scale down. So अगर मैं एक 5 नैनोमीटर पे चला जाऊं, I have some power issues which comes with the scaling down of technology. So that's why what I do, I normally operate for the analog circuit a little bit higher nodes, might be 45, 65 nanometers still, and I get the same benefit. Digital में, when I'm talking explicitly about the processors, mobile phone के अंदर जो processor है या जो laptop में processor है, that is basically the main competition we're happening about 5 nanometer the people are going. So that is basically shown. And one more thing, as we scale down, my cutoff frequency increases. Cutoff frequency is basically the frequency at which my MOS can operate, ठीक है, and this is the maximum frequency. So अब होता ये है कि आप चाहते हैं कि मैं, आपने एक सिग्नल RF का है, रेडियो फ्रीक्वेंसी का, you want to operate at 1 gigahertz, ठीक, so 1 gigahertz में शायद 180 नैनोमीटर ऑपरेट ना करे, but 5 nanometer will operate. So you want to operate at that technology at which your high frequency signal can work. So ये भी एक associated benefit है as we scale down. लेकिन स्केल डाउन होने का एक जो नुकसान है, व्हाट इज दैट थिंग, एरिया का मुझे बेनिफिट मिल रहा है बट पावर गोज अप, ठीक है। नॉर्मली वी हैव टू पावर्स, स्टैटिक पावर एंड डायनामिक पावर। जब मैं स्केल डाउन करता हूं तो जो स्टैटिक पावर होती है, स्टैटिक पावर मतलब जब मैं कोई काम नहीं कर रहा और पावर कंज्यूम हो रही है मॉस से, ठीक है, तो उसको कहते हैं स्टैटिक पावर। तो स्टैटिक पावर गोज एक्सप्लिसिटली हाई, so we need to be careful how we make sure overall power or static power less whenever we scale down. That's why this is a research topic and all the time people work on these things. So benefit क्या हो गया, area goes down, meaning cost benefit in terms of area, frequency goes up, okay, you can target more bandwidth, but power goes up too. वो एक अच्छी चीज नहीं होती, which we need to look into it. So this is basically some image which is being shown here regarding the process of technology for a different band, but because of some issues, because of power issues, we didn't follow the processor speed as intended, but that's like an off topic, that why it didn't go, because again of the heat and the power generation. That's why they stopped at like a couple of gigahertz and then start looking into different innovations. And then anybody have an idea about the wafers? वेफर का आइडिया है किसी को, सिलिकॉन वेफर का? तो जो आपके मोबाइल फोन का जो भी इलेक्ट्रॉनिक्स इंटीग्रेटेड सर्किट्स बनते हैं, अगेन आई एम गोइंग बैक टू दिस चिप, ये एक आईसी है जो गोल्डन कलर में है. सो व्हाट हैपेंस, they are basically developed in a fab, we say ना माइक्रो फैब में होती हैं. दे आर लाइक इन चाइना में कुछ हैं, यूएस में कुछ हैं, एंड ताइवान में कुछ हैं. सो दे आर इन लाइक overall 15-20 fabs in some countries. It's a huge investment, so they are there. So even what do in the fab, they have a complete wafer. एक wafer में multiple इस किस्म की ICs होती हैं and they are being developed. ठीक है. So with the passage of time, again following the Moore's law, जो आपके पास wafer का size है वो बड़ा होता जा रहा है. So you can integrate more ICs in it. ICs के अंदर ट्रांजिस्टर का साइज एक तो छोटा हो रहा था, और वेफर जिसके अंदर आप मल्टीपल ICs रख के डेवलप कर सकते हैं वो बड़ा हो गया बिकॉज ऑफ योर टेक्नोलॉजिकल एडवांसमेंट. तो करंटली वी कैन इवन टच 18 इंच का हम लोग एक साइज, या 45 मिलीमीटर स्क्वायर का हम लोग एक साइज टच कर सकते हैं, सो दैट वी कैन हैव मल्टीपल आईसीज डेवलप टुगेदर. मीनिंग आप ये देख ले, एक चूल्हा ऑन हो रहा है, उससे आप 1 मिनट में ज्यादा आपके पास यील्ड आ रही है. सो अगेन कॉस्ट बेनिफिट इज कमिंग. Again coming back to the Moore's law, cost per transistor is improved due to wafer scaling. So that's also one of the benefit जिस तरह हम scale down कर रहे हैं. This is a diagram of a chip. IC जिसको हम कहते हैं, if you see. So इसमें आपके पास all are basically mainly digital logics. Analog is normally on this periphery, so that will be outside, which is going to be connected at a different technology. But the thing is that as we go down, small is beautiful, looks compact, looks wonderful, but but is expensive because of a lot of other things. Compactness. Previously, we don't have engineers or designers don't have to put much effort in the design. Now they have to put much more effort as compared to the past. So that's why they need to know all nitty-gritties. And the power goes high, so we need to make sure how to do these things. So that's something which a designers basically deal the stuff. And that's what I was mentioning, that okay, we have different scale technology, but for which application we normally use. So all applications which are around, you can see, from healthcare, from the transport, from the energy, from the security, communication, data processing, every technology IC integrated circuits are being used. So there's no where you are not using ICs. But Pakistan, we don't even have any foundry. Foundry is a part, we don't even have design house. Currently, as I mentioned, design house are coming. At LUMS, we are doing a couple of good works in the IC design. That's one of the leading university in Pakistan which are working in the IC design. A couple of university also they initiated. I will describe that in a couple of minutes. But like this is something which can take at least Pakistan in a forefront runners if you want to develop your own products. Software products is one thing, but hardware development is another aspect, which basically needs a lot of these things. Because everything, you cannot have a discrete component. एक कार में आप ये नहीं कर सकते कि मैं ये दो ICs दूं, इनको fit कर दूं and make the things work. No, you need to work at the integrated circuit level to combine those circuits there. So you want smart sensing, you want wireless communication, power control, and also it's linked with multiple domains: chemistry, physics, bio. For example, all your biomedical devices, your all physical phenomena, your electrode sensing, all of the things are interlinked, and then you need to do processing. So mathematics comes. So it's somehow the amalgam which we are having in SSC, it's depicting the same thing. And this is like the nanometer wise, which I mentioned. Okay, analog and RF, we want good, we remain in 130, 65 nanometer. In digital, we definitely want to go for a lower end. We want to go for a 5 nanometer, 10 nanometer. What is the advanced coming? But when we talk about mixed signal, where both analog and digital, okay, it's okay to be in 180 to 65 nanometer to get the maximum benefit from those things. So that's a little bit about the Moore's law. And then comes the integrated circuit design, which is basically the microelectronics is going to be linked with integrated circuit design. So होता क्या है in IC design में दो चीजें होती हैं, synthesis versus analysis. Synthesis क्या होता है कि आपको कोई स्पेसिफिकेशंस दी जाती हैं कि ये आपके पास एक प्रॉब्लम है, फॉर एग्जांपल ये स्पीच है या सिग्नल है, इसको आपने एम्पलीफाई करना है, ये गेन है, ये फ्रीक्वेंसी है, these things. So these are the specifications for ये नॉइज है, ये एनवायरनमेंट है, आपकी लाइन पास कर रही है 50 हर्ट्ज आपको तंग करेगी. So these are the specifications given to you. Your mind and an analog designer is going to do synthesis of it, meaning it's things based on जो knowledge आप लोग gain करेंगे based on the things, okay, how to do that thing, and will form a circuit जिसको हम schematics कहते हैं. ठीक है? So you will design the circuit based on those specifications, and then what you are going to do, you are going to use, for example, the simulation tool to verify जो आपने simulation, जो आपने circuit specifications की थी, उसका एक schematic बनाया था, whether it meets or no. तो वो कौन करेगा? Simulation tool will help. Simulation tool क्या होता है? LT Spice is a simulation tool, and that is an open source, that is not industry standard, that's used for simulation academic purpose. So we also, as I mentioned, we have an access to Cadence, which is an industry standard tool where we do the real design. So वो भी हमारे पास available है. If somebody is interested, can be an option. Once we do the schematics, then we move forward. Forward बात क्या होता है? We move forward towards the physical design. आपने schematic किया है, transistor place किया, real design नहीं किया. That means the layout. Physical design means you have to do manually the layout. कि आपने ultimately डिजाइन किस तरह करना है, मेटल्स किस तरह आपस में कनेक्ट होंगे, मॉस किस तरह प्लेस होंगे, राउटिंग किस तरह होगी, दैट्स अनदर टॉपिक. दिस इज बियॉन्ड दिस कोर्स. जो लेआउट वाला पार्ट है, दिस इज बियॉन्ड दिस कोर्स. दिस वी नॉर्मली कवर इन एडवांस कोर्सेज. लेकिन इस कोर्स में जो पहला पार्ट है synthesis versus analysis का, where you have some specifications, you do the design and then you verify, ये हम लोग we want to achieve till this point. और ये काम आप अपने जो fundamentals तो आप लोग learn करेंगे, but you want to deliver that in that complex engineering problem. ठीक है? Any question from here? Right. So अब जिस तरह मैं पहले बात कर रहा था कि आप हम लोगों ने चीजें चीट नहीं करना, इसी तरह दो वेज होते हैं. डिजाइन प्रोसीजर में आपके स्पेसिफिकेशंस होती हैं, राइट. सो ओके, आई कैन जस्ट टेल अबाउट अ केडेंस. नॉर्मली ये होता है कि व्हाट वी हैव इन इंडस्ट्री. सो फॉर आईसी डिजाइन देयर आर ओवरऑल थ्री मेन लीडिंग चिप डिजाइन सॉफ्टवेयर, ईडीए टूल्स. ठीक है, जिसकी बेस पे आप डिजाइन कर सकते हैं एंड यू सेंड टू द फाउंड्री. द फाउंड्रीज होती हैं, फाउंड्री को अपना डिजाइन भेज सकते हैं सो दैट जो आपकी चिप है ये डिजाइन होके डेवलप होके आपके पास आ जाए. ठीक है, ये कंप्लीट. तो उसमें तीन मेन कंपनीज हैं. वन इज केडेंस, दे आर बोथ एनालॉग, डिजिटल एंड मिक्स सिग्नल एंड वेरिफिकेशन. द अदर इज साइनॉप्सिस एंड द थर्ड इज मेंटर ग्राफिक्स, करंटली नाउ acquired by Siemens. ठीक है, तीन कंपनीज हैं. Mentor Graphics या Siemens is more for the verification, they are not for the design. Cadence and Synopsys are both for the design, both analog and digital. ठीक है, so we have an access to the complete Cadence tool. वो license tool होते हैं, we get from the Cadence, so it's cost like $30,000 per 3 years. So it's a heavy software we use for the designing, we use for or research work, but again this license academic license, you cannot use it for the industry currently, but you can use for the prototype which we normally use. जिस तरह मैं आप लोगों को बोर्ड दिखा रहा हूँ. Cadence is a software where you place the circuit, अपना schematic रखते हैं, design जिस तरह करके you place the schematic, you verify, and then you will do the layouts, you will do all simulation, and you will prepare the final form, जिसको हम GDS कहते हैं, graphical design system, which basically you send to the foundry for fabrication. ठीक है, हम फाउंड्री को भेजते हैं, वो 2 महीने बाद हमें डिजाइन वापस दे देता है. ठीक है, I have here some ready design which we just got couple of weeks back. I might have, I will show you in a couple of moments. These are the boards, but we also have those chips which arrived couple of weeks back. तो वो भी हैं. So we do the so Cadence is basically the software EDA tool. No, Cadence is basically optional. If somebody want to learn on their own, they can do the things. They will be more than welcome if they want to do, for example, the end project on Cadence. But I will provide the material to you. I will provide all the resources, but you have to work on your own. उसमें जो ये होता है कि I will provide you an access to campus system, since it's licensed software, so you can only use on campus. But normally I use for the graduate courses, I give the student an access from the campus in current domain. So अगर किसी ने interested होगा, then they can I will give an access and they can use it. But again, I will provide the things, I will assist, but it's not for required for the course. It's just for your own learning. ठीक है, अगर आप लोग इस साइट पे excel करना चाहें, you can have it, but we will use mainly LT Spice. ठीक है, but tutorials and all the things, because I use this in the custom IC design and advanced course and the VLSI, so we have the stuff I can provide that with you. So design procedure में क्या होता है? We have the specifications. हमारे पास specifications जिस तरह मैंने कहा था, and then you think and you have some ultimately circuit जो आप लोग design करते हैं, जो I assume by the end of this course you will be able to do this part. लेकिन उसको करने के दो पाथ होते हैं. एक पहला पाथ जिसको मैं रिस्की पाथ कह रहा हूँ, ये वही चीटिंग वाला पाथ है. यहाँ चीटिंग तो नहीं कर रहे, लेकिन आप कर क्या रहे हैं? A person is sitting on the like an LT Spice पे बैठा है, वो उन स्पेसिफिकेशंस को डिफरेंट मॉडल ट्राई कर रहा है, करता रह रहा है, शायद वो 2 दिन लगा रहेगा. ही विल मीट द स्पेसिफिकेशंस, he will not develop his own understanding, he will just use a like a monkey नहीं होता, he just trying the things and it's working for him. अब से next time problem देंगे, he will do the same thing again. उसको ना फायदा होगा, nothing. On the other path, if you follow this path, इसको मैं red से indicate कर रहा हूँ, the wise path इसको कह रहे हैं. He sits on the table, think over it, do some design, and take it to the Spice. Verify. Might be not work. Again, go back, see what he did wrong or what was the thing. Again, go back. Might be he will take 1 week for the first time. but that first week is going to develop his learning curve. And next time it will shorten, and that by the end of this course or by the end of जो भी आप कर रहे हैं designs, so you will learn. लेकिन अगर आप ये risky path करेंगे, you will never learn. All the time you have to sit, you have to spend time, and you might be successful, you might not be, and you cannot answer the things. लेकिन ये जो wise path है, that will basically what I want you all of you to do. ठीक है? So you need to follow the wise path, जिसमें shortcut ना हो. Learning में learning curve जब तक वो थोड़ा सा इस किस्म का, जिस तरह का आपके पास आईवी कर्व्स होते हैं ट्रांजिस्टर के, वैसा ना हो तो फायदा नहीं होता. तो इसलिए मैं कहता हूं कि लर्निंग कर्व शुड बी लाइक दिस. शायद ये किसी का ज्यादा हो जाए, कम हो जाए, दैट्स टोटली फाइन. लेकिन जब लर्निंग कर्व आप यूं लेके जाते हैं ना, तो उसका इतना फायदा नहीं होता, क्योंकि वो फिर रैंप नीचे आ जाती है. इसलिए बेहतर है कि यू फॉलो अ प्रॉपर लर्निंग कर्व, चीजों के सीखें. इफ यू नो वेल एंड गुड, but like try to learn the things as much as possible, because these are going to be helpful for you, जिस तरह मैं पहले बता चुका हूं. So एनालॉग वर्सेस डिजिटल, लिटिल बिट मैंने जिस तरह कहा था कि हम लोग डिजिटल एनालॉग में हमारे पास रजिस्टर होते हैं, कैपेसिटर होते हैं, एज कम्पेयर टू डिजिटल इज रिलेटिवली इजी, क्योंकि उसमें सिर्फ हम लोग जो ट्रांजिस्टर है मॉस को स्विच के तौर पे इस्तेमाल करते हैं, ऑन है या ऑफ है. ठीक है? इसमें वी ऑपरेट ट्रांजिस्टर एज एन एम्पलीफायर, एज अ रेजिस्टर, एज अ कैपेसिटर. हम लोग कैपेसिटर यूज करते हैं, रेजिस्टर यूज करते हैं, करंट सोर्स होता है, वोल्टेज सोर्स होता है, वोल्टेज कंट्रोल्ड करंट सोर्स होता है, करंट कंट्रोल्ड वोल्टेज सोर्स होता है. Hell of things are there in the analog. So that's why analog is difficult. Digital EDA tools can support you more. Analog में design you have to do. So that's one of the main thing, and that's very much demanding outside. In US, analog designers are highly paid as compared to digital designers. Only because of this thing, they need extensive, rigorous skills. They need extensive, rigorous design techniques, and they need fundamental sharpening. So that's why this is very much important skill to learn to get benefit, and that's something which is core electronics. जिस तरह electrical अगर आप engineer हैं, so if something core electronics is this thing. अगर आज से 20 साल पहले it was connecting an ICs and making something, but currently it is something having the things on integrated circuit design level. That's something which is major thing. So अगर आप अगेन बात करना चाहें, जिस तरह मैं बात कर रहा था मोबाइल फोन की, तो ये मोबाइल फोन में जितनी चीजें ये मेंशन हैं, ऑल ऑफ देम आर एनालॉग. आरएफ फ्रंट एंड, आपने सिग्नल कम्युनिकेट करना है, बात कर रहे हैं, इससे एनालॉग सिग्नल. टेम्परेचर सेंसिंग, आप टेम्परेचर सेंस हो रहा है, एनालॉग सिग्नल. टेम्परेचर इज एनालॉग. टच स्क्रीन, आप टच कर रहे हैं स्क्रीन को, एनालॉग सिग्नल. ऑडियो बोल रहे हैं स्पीकर से, बात बाहर आ रही है, एनालॉग सिग्नल. एक्सेलेरोमीटर है जो आपको गायरोस्कोप या वो कर रहा होता है लोकेशन वाइज, you are sitting, standing, or you're moving, whatever those things. So this is an analog signal. Light sensing, light dim है, light ज़्यादा है, analog signal. Battery management, किस तरह बैटरी सिग्नल को डिटेक्ट कर रहे हैं, because that's not a digital signal, it's an analog signal. वोल्टेज कम हो रही है, ज़्यादा हो रही है, analog signal. Imaging, camera, analog signal. So all the things around are basically analog signal. Yes, you do processing in the digital. इसीलिए अगर आप ये देखें, what's happening, these all are analog, and then inside you do digitize and then do the processing, where your microcontroller, microprocessor, FPGA, your whatever you saw, those gates you have seen in the digital logic course, all of those come. So this is then come the digital. Outside all real world is analog. So हमें analog circuits के through ही हम digital पे जा सकते हैं. Path is difficult but demanding and worth putting an effort. So that's what I can only say. And system around us again, just the same thing, iteration. You have smartphones, you have fiber optic data, जो आपके fiber आ रहा है, that is analog. हम लोग सारा कुछ बाहर से export करते हैं. Why? Because we don't have skill set available. Even if we bring, we assemble the things. हम develop नहीं करते, design नहीं करते. Automotive industry, monitoring, control, all of these things come from outside. From China comes, from US comes. Why? Because we don't have skill set. If we have that skill set, we can do the things. So that's what analog circuit can bring us and take us there. And in current era, even there cannot be a separate analog circuit or a digital circuit. They have to learn both of the things. So this is basically linkage of your RF, where the electric circuits are being linked. If you talk about wireless system communication, your electric circuits are linked with electromagnetic waves. You might have taken the electromagnetic course, so where the electrical signals are going to be linked. Optical networks, electrical circuits are linked with light. Micromechanical devices, electrical circuits are linked in MEMS. This accelerometers, gyroscopes, mechanical induced memristors. So all of these things come into that category. Bioelectronic applications, where the electrical signals are going to be linked with your your body when you want to acquire any signal from your body. Glucose sensing, all of these things are analog signals. So here, everywhere electric circuits come. Okay, so for that one, we need to have our electric circuits knowledge also refresh, devices knowledge refresh, and then we can just tweak the things a lot better in a sense. So अगर हम एक application की बात करें, this is a common for any, let's say ना system, जिसको मैं system की बात करूँ, this is for one specific system, लेकिन कोई आपके पास sensor होगा, वो सेंस कर रहा होगा जिसके अंदर एनालॉग सिग्नल होगा, ठीक है। उसके बाद सिग्नल कंडीशनिंग होगी, वो यू वांट सम फिल्टरिंग, यू वांट टू गेट रिड ऑफ सम नॉइज, कुछ एम्पलीफाई करना, यू विल डू दैट थिंग। उसके बाद क्या करेंगे, यू वांट टू डिजिटाइज दैट डाटा। डिजिटल मतलब हम डिजिटल में आराम से प्रोसेस कर सकते हैं, माइक्रो प्रोसेसर होता है जिस तरह बात कर रहा था, वो काफी छोटी टेक्नोलॉजी में चला जाएगा। सो वी विल डिजिटाइज यूजिंग एनालॉग टू डिजिटल कन्वर्टर एंड देन विल डू डिजिटल प्रोसेसिंग। उसके बाद क्या होगा, मैंने प्रोसेस तो कर दिया, मैंने उसको कम्युनिकेट करना है बाहर की वर्ल्ड में, अगेन एनालॉग सर्किट से मैं उसको प्रोसेस करूंगा। उसके अलावा एक चीज होती है टाइम रेफरेंस, जिसको अगर आपको याद हो कोर्स लर्निंग आउटलुक में चीज थी PLL या ऑसिलेटर्स, इसे कहते हैं फेज लॉक लूप। सो हम लोग जो क्लॉक होती है, वी आल्सो वांट टू जनरेट अ क्लॉक, तो जो एक हाई क्लॉक जनरेट करते हैं ऑन चिप, उसको कहते हैं PLL के थ्रू करते हैं। तो वी नीड टू हैव अ टाइम रेफरेंस सर्किट, ताकि सारे ब्लॉक्स एक ही क्लॉक पे ऑपरेट करें। हम नैनोमीटर में है, 5 नैनोमीटर जिस तरह आप बात कर रहे थे, तो 5 नैनोमीटर पे मैं ये नहीं कर सकते क्लॉक बाहर से दूं, कोई सिग्नल दे दूं, क्लॉक दे दूं, and then all of the things operate at the same clock. It's not possible. I need to generate an on-chip clock so that they can operate at a same frequency. This is not going to be covered in this class, but just to give an idea कि PLL होता क्या है. Again, we in this course we are mainly going to focus on the analog circuits, which is going to deal with the real world. Nowadays, it's all about low power, small size, better performance, beating. So all of these things are there. What I request from all of you, revise your fundamentals, have knowledge of basic circuit में आपने resistor, capacitor, transistor, diodes देखे थे, make sure to review them. KVL, KCL, superposition theorem, Thevenin, Norton should be revised because you will need these things. Frequency response, we will cover them explicitly. Most likely you are taking in parallel. But अगर आपने पहले लिए हैं Laplace या Fourier, make sure also revise them. But otherwise we will follow up them on properly here. Basics of nonlinear circuits, biasing and small signal जो आपने devices के course में लिए थे, IV patterns. Just make sure to have a revision of these things, and we will just jump towards the amplifier design from the next lecture, where you are going to see how we can combine that small MOS to amplify the signal and doing the small studies. Outline will be uploaded today, so you can follow with them if there is some confusion. And just to link in the next lecture, since previously आप लोगों ने तो BJT पे भी focus किया था, bipolar junction transistors. Nowadays MOSFET, metal oxide semiconductor is mainly common. So the BGT is current control device, MOSFET is a voltage control device. We are going to use MOSFET. MOSFET is currently utilized in industry. Now more than 90% consumables or even more are MOSFET based. BJT though are low current operations, and MOSFETs are high power operation for high power applications. But now because of mass production, which is integration, MOSFETs are preferred. BJTs, as the name described, have multiple junctions, P to N and N to P, but whereas MOSFET has a unijunction, don't have multiple junctions. One of the issue for BJT, apart from integration, is power inefficiency, where the MOSFET handles the power efficiently. So for the integration, it mainly helps. So BJTs are less common nowadays, and MOSFETs have all the market there. So that's why we'll start with the MOSFET design from the next lecture, and hoping you will have a very much nice journey. But just to motivate what me and Dr. Wala have done at LUMS, so these are all the chips which we have done at LUMS, verified at LUMS. So this is using 180 nanometer. I didn't mention the cost for 5 nanometer because that's way too much costly. Even 180 nanometer, which we normally work, since we work in the mixed signal, both analog and digital, it costs $1,000 US per millimeter square. So this is a 4 millimeter square, 4 cross 4, 16 millimeter square. So this chip, like this size chip, which I was showing you here, this only developing of this chip for a prototyping cost $16,000 US. But the benefit is that you do the prototype, but when you go for the mass production, you get the major benefit. In the mass production, then ultimately this cost, which is I mentioned 16,000, when you have a bulk order about 1 million of this thing or 100K of this thing, this might become $2 or $4. So here the main benefit starts coming. For prototyping, yes, it's costly, but later on it gives you benefit. So that's like somehow the things. So these are the chips which we other worked on. This is like if you want to see the layout of the chip, which is I was saying the physical design using the cadence. All of these things are developed using cadence. So this is the chip. So here there is some amplifiers in this area, digital circuitry in this area. So all of the things are embedded in it. And again, to show some chip galleries. This is for all our application currently are focused on the biomedical. This is for anesthesia monitoring. This is for the ECG, for the autism detection. And this is again for the autism detection, where you can detect the, from EEG signal, you can detect the emotions, like how you are feeling, and then you can decide the mood swings. This is for the ECG, for the arrhythmia, after ECG se data leke, and we decide about the patient scenario. All of them are targeting biomedical and the wearable devices. So these are all the things we have developed, and if you want to be part of it, you can also be part of it by learning the skill set and by jumping into the cadence even. So that's what I want to show all of these things. So this is for the glucose monitoring. Currently non-invasive glucose monitoring is common. So we are also having some solution. So that's also chip was done. So these all the chips which are done at LUMS, and this is for the sleep. So the purpose of showing these things are that okay, it's not only what we are talking is in the book, it's something fundamental, just state of the art. Because these all the things are making us all going to make LUMS the leading university. Currently, we are leading in Pakistan for the IC design, but hopefully we are planning to lead with all of you with your interest in overall world, or at least in Asia. And that can also only be done by the students. So I encourage you, all of you, who have an interest, you can talk with me, with Dr. Wala, you can just see the things, and you can also get interested if you have some interest in the analog or in the digital or overall in IC design, where you want to design something what's inside the mobile, what's inside the processor, you can do that thing. Applications are not limited to biomedical. So I'm hoping we are going to have a very much nice journey in this course. Okay. So if you have any questions, concern, I can take now, and I will upload the recorded lecture, and the next lecture is going to be taken by Dr. Wala. If there is no concern, no lecture, you can just, if you want to go, you can go. We might not have more content today, but if you have any questions, query, please feel to ask. I am available. And also you can ask any query after the lecture. It's not like you have to ask now, you can ask later. Okay. So I'm hoping we will have a very much nice journey, and where all of us will learn together. And just again, if you have any query anytime, please make sure to jump into it and update. All right. So thank you, and I will just stop the recording, and then I will upload the lecture once it's ready. Sure. Okay.